want to welcome everyone who's joining through Zoom, and I'll do my best to make sure that you're able to participate fully. Before I introduce our speaker, I want to read you the university's expression of gratitude and acknowledgement of the land that we're meeting on. The University of Utah has both historical and contemporary relationships with Indigenous peoples. Given that the Salt Lake Valley has always been a gathering place for Indigenous peoples, we acknowledge that this land, which is named for the Ute tribe, is the traditional and ancestral homelands of the Shoshone, Paiute, Goshute, and Ute tribes, and is a crossroad for Indigenous peoples. The University of Utah recognizes the enduring relationships between many Indigenous peoples and their traditional homelands. We're grateful for the territory upon which we gather today. We respect Utah's Indigenous peoples, the original stewards of this land, and we value the sovereign relationships that exist between tribal governments, state governments, and the federal government. Today, approximately 60,000 American Indian and Alaska Native peoples live here in Utah. As a state institution, the University of Utah is committed to serving Native communities throughout Utah in partnership with Native nations and our urban Indian communities through research, education, and community outreach activities. Let me now introduce our distinguished speaker, Dr. Joey Stanley. He earned his PhD from the Department of Linguistics at the University of Georgia in 2020, and he is currently an assistant professor in the Department of Linguistics at Brigham Young University. He works primarily in the areas of sociophonetics and dialectology, and he makes use of both statistical and computational methods while conducting his research. His dissertation research focused on the spread of vowel patterns in the western part of the United States. His work both then and since then has allowed him to help develop more powerful methods for acoustically analyzing vowels and vowel trajectories. These methods have made it possible for sociophoneticians to pursue questions that they previously could not address. Today, he's going to speak to us about what vowel formant trajectories analyzed through these improved methods can tell us about language change. Let's welcome him with a round of applause.
I'll take my mask off too. I don't think I've ever been introduced before, so this is pretty exciting for me. I'm like super excited to be here. I've never been up here on this campus before, even though I went to school at BYU, and it's beautiful here. All these like the fall colors. I was here about an hour ago, just walking around. Beautiful campus. Love it here. Okay, so today we're looking at vowel formant trajectories, and so this would be pretty entrenched in sociophonetics, and so I like to work with vowels, and so we'll hear a lot about vowels from all over the United States today. So to get us started, American English vowels are going to be are variable in pronunciation. So the way that people pronounce these vowels varies, and this is how a lot of American English accents are differentiated, and we can categorize these differences into two main types of this kind of variation. There are things called vowel shifts, where a vowel's position in the perceptual space appears to shift. It sort of goes up or down or back or forward. So one example of this is my student's a vowel is usually lower and more centralized than my a vowel is. It's sort of as part of this shift that sort of started in perhaps California, has sort of spread like wildfire. If you're under 25, you probably have this same shift. But I pronounce oo as a fronter vowel more than my grandparents do. And so I have some of these shifts too. The other type of change we can see is that sometimes as these vowels are moving around, they sort of encroach on another vowel's space, and they sort of become one. They just merge there. So for me, the words cot and caught are not pronounced with the same vowel, but for 95% of my students, they are. And if you're from the West, my guess is they probably are too. And in Utah, and you get words like feel and fill that are often pronounced close to each other, if not the same. And so these two different kinds of historical changes where you get mergers and shifts are the two main types I'm going to talk about today. And so as we see language change happening, what we see is that there are these language innovations in vowel pronunciations that sort of shift, and they spread from one person to the next and one community to the next. And one region to the next until they sort of spread across the entire place. So let's look at English vowels here. Here's sort of this idealized vowel chart that sort of shows where American English monophthongs tend to be. We can conceptualize what a vowel shift is like. For example, we can take the oo vowel, which for me is pretty close to that spot there. So it's not in the canonical high back spot like you might expect if you look at the IPA chart. And my guess is for probably most people here, if you're a native English speaker, then your oo vowel is somewhere around there too. With a chain shift, we can see this. So here I have the front lax vowels highlighted, and this a vowel is lowering and centralizing, so it becomes the new lowest vowel. And then the a vowel and I vowel sort of follow suit. So that the word bat sounds a little bit more like bot, and the word bet sounds a little more like bat, and the word bit sounds a little bit more like bet. And so you get these sort of shifts that that they influence each other into these things called chain shifts. With a merger, you get this low back merger where there are two vowels that were historically distinct from each other, but now they've merged into one. So for me, cot and caught are not undergoing a merger, but for a lot of people that are from the West, they are. So this a vowel, as in C-O-T, merges with C-A-U-G-H-T, so that they get pronounced the same. So this is what it looks like sort of in this idealized form. If we look at the actual phonetics and pronunciation of this, we can take a vowel that is treated as a canonical monophthong, and we can see its vowel formant trajectories. And so you can see the mouse here very, very small. We're mostly concerned about the lowest two formants, which are these black bands here, and these correspond to as you pronounce a vowel sound, your tongue is in a certain spot, and it sort of creates these resonant chambers, and it emphasizes certain formant or certain frequencies, and we call these formant frequencies. And so here, F1, which is the lowest one, is down here, and it's because this is a canonical monophthong, it's sort of stable, meaning it's just horizontal. Whereas F2 here might go up a little bit, and so part of this has to do with just because of the way we pronounce that velar sound there. And so there is going to be some change here. And so the change that we see in these canonical monophthongs are usually chalked up to articulatory steps, like, oh, well, it's really a monophthong, but there's going to be some formant change because of the way we pronounce our G's, and because we're not robots and can't shift from one spot to the other. We are humans, and our tongues are relatively slow, so it takes time for these things to move, and so we can see how fast that movement happens. If we compare this to a canonical diphthong like we have here in the word thrive, you can see that F1 sort of has a sort of a curvy shape here, and F2 sort of has a curvy shape here. And so this is a canonical diphthong. Now, if you're like me, you're like, I don't see much of a difference here. And so that's sort of one of the things that I don't like the acoustic differentiation between monophthongs and diphthongs. I think everything is a diphthong, but that's just me. Okay, so how do we study monophthongs and diphthongs? Well, if we have something like in the word beg, and then something like I, as in thrive, we can see that sort of sits here in one spot in the vowel space, and I sort of starts low and moves somewhere to the higher frontal portion of the vowel space. If we want to study a monophthong, we just take the measurements at some center point of that vowel and say that's representative of it. But because diphthongs have inherent movement in them, you can't just study one spot. You have to take measurements at least more than one spot. And so we can do some math. This is like 7th grade trigonometry. You're getting the hypotenuse of this triangle here. So you're getting the rise over run, the change in x over change of y, take the square of both of them, add them together, take the square root of that, and you can get the length of that line, which shows how far in the vowel space this vowel moves. And so this is something that people have been doing to sort of quantify how diphthongal a particular vowel sound is. Well, the problem with this is diphthongs don't move in a straight line. They often have some degree of curve to it. And so they say, well, we can take this same thing. We have this sort of curvy shape here. We can just take from the onset to the midpoint and then get the midpoint to the offset. And yeah, it's not going to be the exact length of that arc, mathematically speaking, but it's going to be the sum of those two lines, which would be pretty close. And so, and then we can also take information like how long that trajectory was in actual time and divide the length over time, and that'll give us the rate of change. So how fast is our tongue moving as we say these diphthongal sounds. So this is how we would study these kinds of things. Okay, my problem with this is that I believe there's this false dichotomy between monophthongs and diphthongs. Now, phonologically speaking, I think it's true, and it's good to keep those separate. But phonetically, I don't see a difference between monophthongs and diphthongs. Like, I don't know why we're not applying diphthongal techniques to monophthongs. And so by treating monophthongs as static units, we're ignoring any potential diphthongal stuff to it, because we just sort of assume that it's not going to be important. And even when we study diphthongs, we're not capturing the full information. We're sort of getting information about the trajectories, but we're not studying the trajectories themselves. And so what kind of nuance are we not capturing when we study this stuff? So here is a picture to sort of illustrate. Now, if you didn't know anything about gravity or humans, you would see this and say, my 5-year-old daughter is flying, right? But we all know, because we know how physics and humans work, that she's not flying. She's actually in the middle of a jump there. And so there's information that we assume is there, but we don't actually know. Maybe she was flying here. But we know this because we know how physics and stuff work. The problem with that is we don't know how monophthongs work. And so if we just see a midpoint, we don't know what what happened before and after that monophthong id. And so we can't make we can't, there might be some nuance that we're not quite gathering when we study these kinds of things. To show this in, so with some acoustics, here is someone saying the word Jackson. And here the sound is a canonical monophthong. And so if you wanted to study these, you would take a pair, you would measure the acoustics of the midpoint there. So you'd find where the F1 is, where the F2 is, and call it good. But the problem is, I don't know about you, but I can see some very clear curves in this vowel that is supposed to be a monophthong and something that's supposed to be static. And so people say, yeah, well, it's just phonetics. It's because of the previous consonant and the following consonant. But are we okay assuming that that the entire curve can be completely attributable to phonetics? Or do you think people can manipulate that trajectory in a sociolinguistically meaningful way? Furthermore, even with things like diphthongs, if we take measurements at the onset, the midpoint, and the offset, there are multiple shapes of curves that can fit those same points. And so here is just some idealized examples, but if we have these same 3 points, I've sort of drawn three lines that pass through those same ones. These first two are hypothetically possible. This one is just sort of weird. You don't really expect that. But in theory, it could happen at some point. And if you only take points at three points along the vowel's duration, you're not going to capture that kind of nuance. So what has been happening recently, and how can we better study these kinds of things? So now it's easier to extract trajectory data. So there's this software that came out in about 10 or 15 years ago called FAVE. It came out of UPenn, and people have been using it for a lot of things to study American English. And it's good because it captures diphthongal stuff. It'll take formant measurements at 5 points along the vowel's duration, which is good, but it only works on English, and it has built-in assumptions about how English should work, and so it doesn't quite work so well in like Australian English or non-standard varieties of English. And so there's a new tool that has come out called Fast Track, and it's sort of in the beta process still, but it seems to do a much better job, and it's not language specific. So I've seen people use Fast Track on Hawaiian and Yiddish, and it seems to work great. And it can produce much more nuanced trajectory data, and it seems to be a lot cleaner than FAVE. And so with some of these new tools, we can analyze trajectories better. And then there have been some recent developments in stats. Okay, so because computers have gotten good, statisticians are smart and they found new ways to come up with more and more complex models. And so there are these things called generalized additive mixed effects models, which I believe are ideally suited for studying vowel formant trajectories. If you think of a linear regression where you fit a straight line to some cluster of points, imagine each one of those points is an entire trajectory. And so we're fitting sort of a curved line to all of those points together. It's pretty cool, and we'll see some of this stuff later on. So with these new tools, we can analyze the trajectories themselves rather than just properties about the trajectories, which I think is an important distinction that we're trying to make here. Okay, I'd like to pause and do a mini Q&A to make sure you guys are all with me. So does anybody have any questions so far about what it is that we're trying to do here with monophthongs and diphthongs and trajectories? If not, that's fine, but I want to pause, give it time to digest, ruminate. Okay, if there are no questions, then we'll go ahead and move on. So here's sort of the overview of what I want to do for the next while. And I have 3 case studies that I want to look at. One is where I take some data and I find that as a vowel shifts in the vowel space, like as the vowel midpoint shifts, the trajectory also changes shape, which is kind of a cool new finding that we've never really seen. Case study 2 is a case where a vowel is shifting in the vowel space, but the trajectory is not changing. So the trajectory is more or less static and it sort of moves as if you copy and paste this whole thing over. And then case study 3 is when we look at merger, and we can see how trajectories play a role in vowel merger itself. Okay, so let's look at this first one. Vowel shifts change with trajectories. So here's me, and this was me when I was doing my dissertation fieldwork in Longview, Washington, which is in the southwest portion of Washington State. And I was interested in this thing that I'm calling the elsewhere shift. Now, it goes by lots of names. It's called the California vowel shift, the Canadian vowel shift. I think people are now calling it the low back merger shift. Lots of names. I'm calling it the elsewhere shift because geographically it was once elsewhere. It was sort of not the south, not the north. It was everywhere else. Now that's not true because we found it in Georgia and in the south, in the north, and in the northeast. And so it's pretty much everywhere now. This is that thing I was saying, where if you're under 25, you probably have this shift. And what the shift is it starts off with the low back merger, and so the cot and cot sort of become the same, and then the front lax vowels sort of do this counter. I guess that's counterclockwise shift there. It's also called the elsewhere shift, I believe, because it only applies to the elsewhere allophones of these vowels. So it does not happen before nasals or laterals or other things. It's only before obstruents, which is sort of the elsewhere allophones. And so to me, the elsewhere shift seems to be like a good name, but I think I'm losing that battle. Okay. And so my dissertation, one of the things it does is it analyzes the vowel trajectories of this shift for the first time. There have been lots of studies in the past 5 years that have looked at this shift, but everybody has been using midpoints. And I was like, well, I think there's stuff going on with the trajectories. As far as how this data was collected, I'm just going to summarize it really quickly so I can more focus on the methods. But if you guys have questions about how it was collected, I'm more than happy to answer those in the Q&A. But this was based on sociolinguistic interviews that I did about five years ago. Something like 45 hours of data, 128,000 vowels were analyzed here. And then how it was processed was using pretty typical techniques. Fast track wasn't invented yet, so I just wrote my own prot script, filtering things out, doing sort of normalization and transformation and stuff, and I can tell you guys all about that later on if you really want. The important part here is I used generalized additive mixed effects models to model these vowels, and so I can show you a plot that shows how the trajectories themselves change. And so here is that plot. Now, there's a lot of stuff going on here. So I want to sort of highlight a few things. So one, if you look up here in the corner, this is a zoomed in version of the low front portion of the vowel space to get yourself sort of situated. So here I'm just focused on the a vowel, so as in the word bat. Okay, so we're just sort of zoomed in on that portion of the vowel space there. The plain ends of these lines represent the vowel onsets, and the arrows represent the vowel offsets. And so you can sort of see it. So when I say bat, it's sort of like bat, it sort of goes from left to right. The thicker portions of these lines represent a slower rate of change, meaning my tongue or whoever's tongue this is moving slower, whereas the thinner portions is when the tongue is moving faster. So if you think of a quill pen and you drew this with a quill pen, the slow portions is when the ink pools and it's thicker, and the fast portions are when it's thin. The dots themselves represent the midpoints. And so if I were only to do a midpoint analysis of the data, I would only get these 4 dots for the women and then for the men. The colors here represent generational cohorts. And so the oldest is the silent generation, which is people born before World War II, it's between about 1924 and 1944. Then I have the boomers and sort of the next darkest, and then Gen X, and then millennials. I think my youngest person was born in 1997. Okay, so here's what this looks like. Now, if we just look at the vowel midpoints, what we see is that, yes, they do go down, and they do go further back in the vowel space. And so the same kind of shift that we've seen in California and Canada and all these other places, we found it in Washington too. But that's not really that surprising, because basically everybody has this shift now. And so it's not terribly remarkable that I found the shift there. But what you see is that there's a change in the trajectory shapes. The older ones tend to have maybe a V-shaped one that is wider in sort of the front back thing. And as you get younger, it sort of goes down and points to sort of what I'm calling a bounce shape. And so you see this among the women here in the red, and also among the men here in the blue, where the older generations have more change in the F2, like the front back space. And as their vowel lowers and becomes more centralized, the formant trajectory itself sort of narrows, and so there's less change in the F2 space. So that to me is kind of a cool finding, because as far as I know, no one else has found something like that. And so this sort of augments what we know about how vowels change, because as these vowels move in the vowel space, the trajectories can also change shape too. And so we're adding additional data that previous studies haven't really found. So that's kind of a cool thing that we've seen. And so this sort of adds to what we know about language change, because we can see that it's not just the global position of the vowels that are changing, but it's the whole shape of that vowel. Okay, let's move on to the opposite case, where vowel shifts change without trajectory changes. This is based on a paper that's forthcoming in the Journal of English Linguistics with some of my colleagues from the University of Georgia. So this is based on Southern American English, and we're looking at back vowel fronting. So here I'm looking at the oo and the o vowels, and it's pretty much it's pretty strong what you find in Southern American English that these vowels become quite fronted. So instead of something like ooh, it's something like oo, or something like o becomes like the word goat sounds more like goat, o, where it sort of starts off more towards the front. Oo fronting is more extreme, and it's an older shift, and it's been going on since perhaps right after the Civil War. O fronting is newer and perhaps started maybe around the turn of the century or somewhere around then. And you don't find O being fronted nearly as far as oo is being fronted. For some Southerners, oo is truly a front vowel, and it's sort of like in the IPA symbol Y. It's this true front vowel there. We find back vowel fronting in pretty much every variety of North American English except for like the North. So like Minnesota is one of the few places that doesn't really have this. And then some ethnic varieties like African American language tend not to have back vowel fronting. But today we're focused on the South. And there have been a few people that have talked about vowel trajectories with these vowels in Southern American English. So Coop's 2010 is one of the main ones. And he shows that how Southerners have vowel trajectories with the oo vowels not quite the same as how non-Southerners do. So as far as how this data was collected, so this is based on linguistic atlas interviews that were done in the early 1970s all the way to maybe the early 1980s. These were field workers found very old people. So these are so there are people born as early as 1886, and I think the youngest was born maybe in the 1960s. And so these were recorded on reel-to-reel stuff, and they were digitized at the University of Georgia. And so here we're looking at around 89,000 vowel tokens from 48 speakers. As far as how this was processed, we had a lot of help from a lot of undergrads to manually transcribe all of these. And we used pretty typical techniques to process this stuff. Here we fit generalized additive mixed effects models once again, and so we can start to see the same kinds of plots. Okay, so here is what this plot is like. So here, down here, you can see that I'm focused on just the back half of the vowel space. And I'm just showing, or I'm showing 5 vowels here, split up by gender and by generation. And so the darker ones, once again, are the older people, and the lighter one, no, sorry. The darker ones are the younger people, and the older ones are the lighter ones are the older people. So the older people sort of fade away. And so, but otherwise you can interpret these plots more or less the same way. Now there are a few things to pay attention here. So one is that the U vowel is quite front, O vowel still isn't that fronted. So this is sort of evidence to show that O fronting is not quite as old. And then cot and caught are still quite separate from each other. So at least among the silent generation and among baby boomers in the South, those two vowels were not merging at all. I want to focus on just this O vowel here. And so I'll do a separate plot here. So it's just the O vowel. So I'm just looking at this high mid-ish back portion of the vowel space. Now, so something that you may notice is that more or less the shape of these trajectories is the same across generations and between the two genders. Now, this is something that's not an artifact of the modeling. So each combination of gender and generation had the model was able to fit a separate curve independently of everybody else. And so it's not an artifact of the modeling. It does just appear to be the case that as this vowel shifted, the trajectory did not shift. Now, it may have changed sort of size, so it may have stretched a little bit, but the overall shape is more or less the same. And so as this vowel sort of gets fronted, as it goes from, let's see, we're going, yeah, GI is the oldest, so it sort of gets fronted with perhaps some lowering as well. So the overall position of this vowel is changing more towards the front, but the shape of that vowel is not changing, which is the complete opposite of what I found in Washington, where as the vowel shifted, the trajectory itself changed. Okay, so that's case study number 2. I want to get into case study number 3 now, and this is in collaboration with Lisa Johnson, who just graduated from the anthropology department here last year, and she's now at BYU. And what we are looking at is vowel mergers in Utah English and how vowel trajectories can help us understand what's going on with these mergers. And so this is a preview of what we will talk about at the Linguistic Society of America conference in a few months. So going back to these mergers, so we're looking at prelateral mergers. So it's not an unconditional merger like the caught one, but it only happens in certain contexts. And here we're just focused on vowel sounds before L's. So if I add to this, you can see the kinds of words that fit into each of these categories here. Now, it's kind of hard to talk about some of these, especially if you have a merger. So I for example, merge these two here, P-U-L-L and P-O-L-E. And so it doesn't make sense to talk about pole and pole because they're the same sound. And so what I'm going to do is use these keywords that should help disambiguate what I'm trying to say. So it doesn't make sense to talk about pole and pole, but it might make more sense to talk about wolf and jolt. Okay, so if we look at these prelateral mergers in the context of Utah English, it's been shown that the tense lax distinction between vowels tends to get lost before prelaterals, or before laterals. You find this in other places too, like Texas and other parts of the South, but it seems to be pretty strong in Utah. And whether that they're fully merged or not is still maybe up for, the jury's still out on it, but it seems to be the case that these pairs tend to merge. In the back vowels, it gets a little more complicated. So basically every combination of pairs of vowels in the backspace can merge in in some people. I think I surveyed my class of 35 people, and there were like 6 different kinds of mergers going on just in the back portion of the vowel space. And these are all people that are mostly from Utah. So it gets pretty complicated. So we'll just focus on the wolf and jolt, and maybe the mulch and jolt one. So how do vowels merge? Well, there have been several theories that have been shown, and data-driven type stuff. So one is this thing called a merger by approximation. And here's my animation of that. So let's say I have two different vowel classes, and over the course of several years or several generations, people and younger people will pronounce these 2 vowels closer and closer to each other, to the point where they overlap and they take up the exact same space, at which point they become the same vowel, and people can't differentiate between them. So that's called a merger by approximation. That was shown, that was found in England, and it's been shown in lots of other places. There's this thing called a merger by transfer, though, where it's not phonetically gradual, but it's lexically gradual. So one word at a time, it'll sort of jump ship and jump to the other vowel class, to the point where all the vowels eventually jump to this new one. So you still have this separate vowel, and it's still distinct, but they sort of jump one word at a time. That's called a merger by transfer. And then there's one called a merger by expansion, where you have 2 vowel classes, and then suddenly the distinction between them no longer matters. And so you just have this sort of explosion of vowels where the distinction between the 2 of them is just gone. And these usually happen very quickly, sometimes in the course of just a single generation. So these are ways that I've animated them, and they might help you understand what's going on here. So these various mechanisms of merger have been proposed and have been found in various places across the world, and there have been a few more, but only one of them has talked about vowel trajectory, and it did so in kind of a rudimentary way. It was sort of looking at stuff in Southern American English with glide loss, and I don't think it did a very good job at it. And so the question I have is, what role do vowel trajectories play when you're looking at vowel merger? So that's what me and Lisa Johnson are trying to explore. So here, for just to give you back, get you grounded in what this is like. So here's the word peel, and you can see that even though the E sound is supposed to be a monophthong, you can see there's a lot of movement going on here. And yeah, that it sort of transitions to this dark L sound, which for some people may not be an actual consonant, maybe just sort of this backish vowel. But there's a lot of there's a lot of movement there, and so we think trajectories probably play some role in some way. So that is what we want to find out, is what role do these play. As far as how this data was collected, this was based in Wasatch County, so just Heber, just down, I guess, up the mountain. I don't know what, over there. And this was mostly just wordless, and I collected this data a few years ago. Mostly wordless snowball sampling. I do have a couple sociolinguistic interviews up there, but it's a much smaller data set. As far as how this was processed, I'm using more newer techniques, I suppose. So here I do start to use fast track, and I am using generalized additive mixed effects models. Now, in the previous 2 case studies, I modeled time as generational cohorts, and that was because of the messiness with the data. I just couldn't measure model year of birth as a continuous factor. Well, here, as it turns out, I think I have something here. Birth year is modeled as a continuous nonlinear predictor, and the reason, it's cool because I can make some pretty cool plots with this, and so I'm really excited to like show off some of these fun plots. Okay, so here is what the vowel space looks like. This is sort of the top 2/3 of the vowel. Each color represents a different vowel class, and even though age was modeled as a continuous variable, it's hard to visualize that. So I've sort of taken this at 10-year intervals. And so you can sort of see what's going on here among zeal and guilt, which is this sort of feel thing. They're not quite merged, at least not in this data. Same thing with flail and shelf. These 2 are not quite merged, but you can see there's some massive merger and stuff going on here.
Sorry, I hope this isn't interrupting, but I was just wondering if you took into account how long people have been living in this area.
All of them were born and raised there. Yeah, so which is harder and harder to find because Hebrew is exploding. So yeah, these are all people born and raised, which sort of gets at the question of what it is I'm actually modeling, because there are a few people that are born and raised. Anyway, yeah, so these are all folks born and raised there. So there are a few things that I'd like to point out. So one is that these don't represent the entire vowel length, because it's really arbitrary to try to divide where the lateral starts and where the vowel ends. And so what I did is I combined the vowel and the lateral into a single unit, and then took formant trajectories along the entire thing. But since most of the last half is mostly lateral, I'm not really concerned about that. So here, the onset of these is 10% into that vowel lateral pair, and then the offset, or the arrows, are like the midpoint of that. It's sort of an arbitrary cutoff, but that's sort of the best I could do. So things to see is that zeal is not the same as guilt, but it seems to be moving towards guilt. And so it seems like that younger people are more on the path towards merger than older people are. It's been proposed that spool is merging with perhaps wolf or jolt, and here there's no indication of that. Spool seems relatively stable and is pretty far away from the other ones. But here you can see there's a lot of stuff going on, and so I'll have to dissect that further to see fully what's going on there. And there's this massive raising of the mulch vowels. This is words like adult and cull and dull and pulp. That vowel is becoming more and more raised to merge with the other ones. Okay, so with the generalized additive mixed effects models, I can do some pretty cool things, and I can do this thing called a difference smooth. Now, this is a new kind of plot that you probably aren't familiar with. So here's a bit of a tutorial. Let's say we have two formant curves. So this is in like what you see in prot. We have two vowels that sort of do. We have a red vowel and we have a blue vowel, and they have their own formant curves. What we can do is we can fit a gam to this data, and it'll sort of connect the dots in as best way it can, given that there's sort of parameters of how wiggly I can allow this line to be, but it can sort of fill in the gaps there. What I can then do is measure the difference between the top line and the lower line at several points along the duration there. And what I can then do is flatten the lower line, but keep the distance the same. And so I get this new shape of a top curve, and that's what's called the difference smooth. So that top line looks like it could be a formant shape, but it represents the difference between those two lines. So that's just what I'm focusing on here. I can then do things like add confidence intervals to that, and then where those confidence intervals don't intersect with 0, then we're calling that portion of the vowel trajectory significantly different from each other. So with difference smooths, we can not only find whether the two vowels are significantly different from each other, but we can see where along the duration of those vowels that significance is. And so it may be the case that you only find significance in the front half of the vowel, but not the back half, or only in the midpoint, but not on the sides. So here are 8 of these different smooths. We have the oldest people here born in 1940, and the youngest people here born in 2000. So let me see. So, and then we have, this is F1, so the lower one, and then F2. So what we can see is that older people, so this is focusing on zeal and guilt, so this feel-fill merger. Older people distinguish between those two vowels for pretty much the entire length of the duration of the vowels for both F1 and F2. It's only in the very tail end of F1 that we see some indication where they are merged. However, for the younger speakers, what we see is that it's only in the first half of the vowels that the two vowels are distinct from each other, and towards the tail end of those vowels, they become more and more similar. And it seems to be the case that F2 matches F1. And so what we're seeing is a sort of gradual influence from the right side of the vowel, where the lateral is applying more and more force and forcing these two vowels closer and closer together. Now, here we have just 4 different time points, but what we can do is, because I modeled age as a continuous variable, I can fill in all those gaps. And so if you think of these as the side view of a mountain range, okay, now imagine you're looking at the top of this. So you're looking at a topographical map, and that's what this plot is. And I'm very excited about this. So here, this shows, so the onset of the vowel is towards the left, and the offset is towards the right there. The color means that that portion of the vowel is of the vowel pairs zeal and guilt are significantly different from each other. We have older people at the very bottom and younger people at the very top. And where it's white, it means that the difference between those two vowels is not significant, and so we have this merger here. As far as what the colors mean, darker colors just mean that the significance is, or the difference between those two is greater, and lighter colors means it's not as strong. As far as what the colors mean, it just means one is positive and one is negative. And so this is a pretty cool plot because the overall trend is sort of this sort of diagonal line thing here. And so you can see that the offset of these vowels for the older people is the only thing that's merged. But the sort of the white part sort of gradually spreads leftward as it sort of allows these two vowels to merge. Okay, so the question then is like, so what? Okay, so I found some cool stuff, like why should anybody care? So one is that this vowel plot, if you were to just look at the midpoints, would suggest a merger by approximation, which is the kind where the two sort of gradually come closer to each other. But that's sort of what we see based on midpoints. If we look at the full trajectories, what we see is that it's sort of, at least in this case, it's the vowel, they're sort of squeezing each other from the right portion. It's the L that is causing these things to merge, and the L increases its influence over time. And so if we have two curves that look like this among the oldest people, younger people may have the onsets merged, and the older people, and to the point where they may become totally merged. And so I like to think that it's like a zipper. It sort of zip the two vowels together. Okay, so to conclude here, in Washington, I found that changes in trajectory can accompany changes in onsets. And so this is sort of augments what we know about how vowels change, because the trajectories can change too. But they don't have to, because in the South, we found that the vowels can shift without an accompanying change in trajectory. And then what we've seen is that if we look at trajectories, we can get greater insight into how vowels actually merge. And we'd like to sort of see how this works with other kinds of mergers like the caught merger, but because that merger has been in the West for like 150 years, we don't have anybody that's from the West that doesn't have this merger. So it's kind of hard to get people that don't have it. And so what I would like to do is basically use vowel trajectories for everything that I do, because I think we're overlooking a lot of really useful information, not only phonetically, but I would like to look at the sociolinguistics behind this stuff too. We know that people can change the midpoints of their vowels to index certain things like professionalism and formality. Do people change the trajectories of their vowels as well? And what kind of things can that, what kind of nuance can that convey in a person's speech by changing the trajectories? No one's bothered to ask, I don't think, and no one's looked. And so we don't know what kind of things could be there. And so what I'd like to do next is maybe get some perceptual work done where I can like digitally modify things and play them for people and see and do a very controlled experiment in that sense. And so that's what I'd like to do in the future. Okay, there are the many references that I cited, and thank you for being here, and I'll take as many questions as you guys have them. Yeah, so I have two examples of that. One, okay, good. In Washington, I found that people probably had the caught merger, but if I plotted their midpoints, they were more or less on top of each other. But if I plotted the trajectories, it was the case where one was like this, and the other one was like this. So they passed through the same point at the midpoints, but the diphthong, or the trajectories is what kept them separate. And so that's something that's cool. In the South, you get the vowels in like face and dress, they're often called when they swap. So instead of face, it's something like face, and dress is like Dreas, face and Dreas. And if you look at people that have this to the max, so the face vowel sort of goes up like this, with people in the and dress vowel sort of is more of a monophthong. This is for someone like me. But someone in the South will have a face that starts lower and is more diphthongal, whereas the dress vowel, Dreas, more or less occupies the same space, but it passes through it in the opposite way. And so it does seem to be the case that it's not just the vowel space that is keeping these vowels distinct from each other, but it's how they pass through that space. Yeah. So I think yes, I think it's more than just that space. So as far as I know, the Colloquium merger developed independently at least 2 different places in the United States. It seems to have started in the West, perhaps starting in California, and then also in Eastern Pennsylvania. And the West, it's been here as long as English speakers have been here. So we don't really know how it formed. But in Eastern Pennsylvania, it started pretty quickly in the early 1900s or so. And the explanation there is that there were a lot of mining towns there, and a lot of people came from Eastern Europe to work there as miners. And I don't know much about Slavic languages, but I hear that there's only one low vowel there. And so as these people were learning English, they had a hard time distinguishing between low vowels. And low vowels are just notoriously annoying to distinguish anyway. But as they gain proficiency in English, they seem to be doing just fine without acquiring both of these low vowels. And so children that grow up there, they hear some people that have 2 vowels here and some people that have 1 vowel, and they see that they're doing them just fine. They're like, well, it's more economical to only acquire the one vowel. And so as children are sort of faced with this unconscious choice, they see that their parents, who may have 2 separate vowels, rely on acoustic cues to distinguish between words, whereas people that only have 1 vowel rely on semantic cues. And the semantic cues are usually more trustworthy, or more a clearer indication of what the word is. And so the children's like, well, I'm just going to trust, I'm not going to acknowledge any acoustic differences between these vowels. I'm just going to trust the semantics of it. Anyway, point is, there is a lot of language contact, and so what we get is sort of a watered down version of all the different things going on. In the Western United States, we have a lot of people that settled here early on, and they came from lots of dialect areas. So my guess is something like coinization, where you get lots of sort of you end up with a sort of a watered down version of the vowel space. That's my guess. I don't have a good example of that, and I don't have a lot of intuition on this because trajectories are notoriously hard to hear. Like, we don't cue in on them, I don't think, as well as midpoints. But in theory, if we had a diphthong, let's say we have something like I, to do a very clear case, we have something like I, and it could be the case that someone could just go straight there, and that would index a particular sound, or someone could sort of do this very curved path there, and then this part is slower, so I'll draw like a thicker line, where they sort of start and stop in the same place, but it sounds acoustically different in some way. What I'd like to do is synthesize a bunch of vowel trajectories and exaggerate them more and more to see what like the just noticeable difference is when playing with these things. So and so I don't have a good example of this, but hopefully I'd like to find one. If it's the case that people don't cue in on these things, they don't index anything linguistically, that's fine, but I think it's something that's worth exploring. In theory, there are a few cases of this thing called a near merger, where someone feels like they pronounce the 2 words the same, but they actually don't. And that gets into this weird thing, like, how can someone distinguish between 2 sounds if they don't even know they distinguish between 2 sounds? With the Colloquium merger, it's a little bit tricky because it's not the distribution of the flanking consonants is not even across the two ones. So it's usually the case that if one of the low vowels ends in a G sound, it's going to be the further back one, like I thought, as opposed to lot. So I have a pretty robust distinction between these two vowels, but every word that ends in G has the back vowels, like fog and dog, except for one word, that's cog. And so unless you model the flanking consonants in a sufficient way, you're going to get this artificial separation just because the consonants do have an effect on one sort of control for it. So it gets tricky when trying to figure out whether people have a distinction or not, especially with those paravowels, because the consonants just do weird things. Yeah. I don't know if that was a satisfactory answer, but so if you go to joeystanley.com/u of u, you can download these slides and you can look at the plots and you can sort of zoom in on that. My dissertation has a ton of them, so if you really want more, you can download my dissertation, just blow them up and put them on your wall or something like that. I feel like I enjoy the plots. Like I think more about data visualization more than most linguists, so I spend a lot of time on the plots, and so hopefully they at least can convey something meaningful to you. Yeah. Okay. So to ask the question about what function to use, I mostly use the recommended one too, because I don't know. Well, like GAMs, I like to explain them as like a very difficult beast to tame. And once you can tame them, then you can do cool stuff. But like it takes a long time to sort of like figure out what's going on and what these different things do. And one of the things I have not yet explored is the different kinds of functions and what kind of effect it has on it. So I can't really answer any of that. I think I just used the CS, the cubic spline way as well. As far as duration, so duration was incorporated into these models as an interaction term with all of them. So duration was, as far as I can tell, as accounted for as it could be. And so this in theory goes above it and beyond it, anything we see with duration. Because that's a major problem, because like word lists tend to be slower compared to conversational data, so it's hard to compare those. But if you account for duration, hopefully then you can sort of erase those differences in some way. Yeah. So that's hard. So the earlier two ones, because of the messiness of the data and not having enough data to fit a sufficiently complicated model, speaker was only included as a random intercept and maybe a random slope. In the last one, though, we included speaker as a random smooth, which should account for all that stuff. But usually when I add speaker as a random smooth, it doesn't converge, which is super annoying. It just means like I don't have enough data, but the last one that we saw with the prelateral stuff in Utah, it had a fully specified random effect structure, so it accounted for all that stuff in the best way that it can. So hopefully in the future I can collect better data and more data to be able to do that kind of fully specified model, but sometimes you just can't. You sort of have to stick with what you have. No. And I know multi-syllabic words tend to be shorter and other things going on there. In the Utah stuff, they may have all been monosyllabic. I can't think off the top of my head if they were or not, but since it was wordless stuff, I try to keep that stuff as controlled for as possible. So they may have been all monosyllabic. They can have a coded cluster. So like, yeah, that's a good question. I haven't even looked at that. Yeah, so like a word like bell versus belt. I mean, probably. And if there is an effect, it will probably only affect sort of the realization of the lateral itself and maybe not the vowel, but I haven't checked that. So it could be the case that that could have an effect on the vowel itself. So I'll have to, I'm gonna make a note of that to account for surrounding consonants and whether they're there, because that's something I hadn't thought about. In the Southern data, we had speakers from, well, we weren't the field workers there. So the only ethnicity data we had was either black or non-black, which is like a weird, gross oversimplification. And so for that one, we didn't have enough black speakers to model ethnicity separately, so we just sort of modeled the non-black, which we presume to be white. In the Washington data, everybody was white, not by design, but because Washington's like 95% white. I think there was maybe one speaker who identified as half Hispanic. And then in Utah, I think everybody was white, I think. And then for socioeconomic stuff, it wasn't especially controlled for. In the Southern data, it's mostly working class. In Heber, there was probably a range of that. And then in Washington, it was mostly lower middle class. So some of that was controlled for just because the communities we talked to were more homogenous than others. Like in Southwest Washington, it's somewhat homogenous. So other factors like that presumably can have an effect on the overall shape, and it would be independent of gender and time. So they may change their vowels in a slightly other way, but don't quite have enough data for all those different groups to fully account for all those. Yeah, but that's a good question. I think I asked people, and I think the only one was the woman who said she was half Hispanic, and she said she had some Spanish. I don't think she was even in like a fluent Spanish speaker. So not too much interference from other languages. Yeah, so pretty homogeneous group, which I know like erases all the other marginalized groups that are out there and what kinds of things they're doing with speech, but it's I can only collect so much data, and so it'd be great to explore some of those later on. So the Washington data had interviews and word lists, and the word lists were carefully constructed to target specific linguistic variables that were important in Washington. At the time of fieldwork, I didn't realize this California vowel shift was going to be such a big deal, and so I didn't elicit those vowels in the word list. So I have word list data, but it targets other things, and it's usually not very interesting because most everybody does the same thing. So no, I don't have that kind of difference because the word list didn't target the same kinds of things that the conversation did.
Okay, I think we are actually out of time. Let's give them another round of applause.
Thanks.